If you find this video helpful, please like, subscribe and press the bell icon for notifications. Hi guys, today we will be solving system of equations. So let's do it by using elimination first. So elimination, where we eliminate as many variables as possible from each equation. So for example, let's take three linear equations and solve them by using elimination. So 2x minus y plus z is equals to minus 1 and x plus 2y minus 2z is equals to 2 and x plus y plus z is equals to 1 be three linear equations, and they are equation number 1, 2 and 3. Now let's try to make as many zeros as possible. So let's replace equation 2 as 2 times equation 1 plus equation 2. So equation 1 and 3 will remain same. So 2x minus y plus z is equals to minus 1. Equation 2 will be 5x plus 0 is equals to 0. And it is equation 4 now. And x plus y plus z is equals to 1. That is equation 3. So now we can make zeros in equation number 3. So let's replace it with equation number 1 plus equation number 3, and we will get 2x minus y plus z is equals to minus 1, 5x is equals to 0, and 3x plus 0 plus 2z is equals to 0. Now swap equation number 4 and 5, and we will get 2x minus y plus z is equals to minus 1, 3x plus 2z is equals to 0, 5x is equals to 0. And now from equation number 4, we will get 5x is equals to 0, that is x is equals to 0 here. Now put the value of x in equation number 5, and we will get 3 times 0 plus 2z is equals to 0, which is z is equals to 0. Now put the values of x and z, that is x is equals to 0 and z is equals to 0, in equation number 1. We will get 2 times 0 minus y minus plus 0 is equal minus 1, that is minus y is equals to minus 1, and that is y is equals to 1. So we back substitute until we get values of all the variables. Therefore x, y and z is equals to 0, 1 and 0. Now before moving on, let's talk about few terms that will be needed in solving system of equations. So let's talk about coefficient and augmented matrix with the help of these two linear equations, and these equations are a1x plus b1y is equals to c1 and a2x plus b2y is equals to c2. So writing the coefficient of variables x and y in above equation in matrix form will give us coefficient matrix. Like a1 and a2 are the coefficients of x, and b1 and b2 are the coefficients of y. So we can write these four elements or these coefficients in matrix form, and we will get coefficient matrix. Augmented matrix, where coefficient matrix is augmented by writing the constants c1 and c2, where coefficient matrix and the constants are separated by a vertical line, like a1 b1, a2 b2, and then a vertical line, and then constants c1 and c2, and this is the form of augmented matrix. Now what is row echelon form or simply REF? So for that, let's take an augmented matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 augmented by 1, 2, 0. And now try to bring zeros in this triangle or try to make these coefficient as 0. So after a few operations, we will get a matrix in this form where each leading coefficient is to the right of the leading coefficient in the above row. So like here, A1 is the leading coefficient for row 1 and for row 2 it's B2 and for row 3 it's C3 and B2 is to the right of A1 and C3 is to the right of B2. So each leading coefficient is to the right of leading coefficient above it. Now, if we include one more coefficient, that is 9, and make it 0, 2, then the matrix will be in this form, where we will get 4 zeros, and the row with all coefficients 0 is the bottom row of the matrix. Now let's include one more coefficient, that is 5, and make it 0, 2. Then the matrix we will get is like this, where leading coefficient of row 1 is A1 and for row 2 it's C2, and the row with all 0 coefficients is the bottom row of the matrix. And all the above matrices are in row echelon form. Now majority of books states that leading coefficient must be 1, but according to me it is not required. But please do check with your instructor what he or she wants. So now let's take leading coefficients as 1. And so here leading coefficient in every row is 1, and every leading coefficient is to the right of the leading coefficient in the previous row, and the rows with all zeros are at the bottom of the matrix or at the last row of the matrix, and these are the requirements of a matrix to be in row echelon form. So the requirements for row echelon form are leading coefficients in each row should be 1, but it could be any non-zero number too. Please check with your instructor. Each leading coefficient is always to the right of the leading coefficient in the row above. And third requirement is row with all zeros should be at the bottom of the matrix. So these are the requirements for row echelon form or REF. Now reduced row echelon form, that is RREF. So RREF is basically a continuation of REF. So let's take a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 augmented by 1, 2, 0, and now bring it in row echelon form. Now this matrix is in row echelon form, and now if we continue and further reduce it in such a way that every column that has a leading coefficient 1 has zeros in every position above and below its leading entry, and leading coefficients are 1 here. So if we can bring this matrix like this, where all the leading entries are 1 and other entries are zeros, then it is in reduced row echelon form. Or this is another form of matrix which is also in reduced row echelon form. So the matrix in reduced row echelon form satisfies all the requirements of REF plus leading coefficient in each row is only non-zero entry in its column, and that is 1. Like here, leading coefficient in row 1 is 1, and that is the only non-zero entry in first column, and similarly leading entry for row 2 is 1, and that is the only non-zero entry in column 2, and similarly we can say for column 3 too. Now the Gaussian elimination. So Gaussian elimination uses row echelon form, that is REF, to solve system of linear equations, and it is usually carried out by using matrices. And the valid row operations for Gaussian elimination are swap, that is exchanging any two rows, then replace or replacement, where add a multiple of one row to another row, and third one is scale or scaling, that is multiply a row with a scalar. So these are the three valid row operations for Gaussian elimination, and these are swap, replace and scale. Now Gaussian Jordan elimination. So Gaussian Jordan elimination uses reduced row echelon form, that is RREF, to solve the system of linear equations. So Gaussian elimination uses REF, whereas Gaussian Jordan elimination uses RREF to solve the system of linear equations. And all of these matrices are example of reduced row echelon form because all of these are in RREF. Now let's solve a system of linear equations by Gaussian elimination, where valid row operations are swap, replace and scale. So let's take three linear equations, and these are 2x minus y plus z is equals to minus 1, then x plus 2y minus 2z is equals to 2, and third equation is x plus y plus z is equals to 1. So these are the three linear equations which can be written in augmented matrix by putting coefficients of x, y, z in matrix form and then augmented by the constant terms. So the coefficients of x, y and z are 2 minus 1, 1, 1, 2 minus 2, 1, 1, 1. So let's put these coefficients in matrix form and we will get 2 minus 1, 1, 1, 2 minus 2, 1, 1, 1, then augmented by the constant terms, and the constant terms are minus 1, 2, 1. So write them here, and this is the augmented form of the linear equations. Now the augmented matrix is 2 minus 1, 1, 1, 2 minus 2, 1, 1, 1, augmented by minus 1, 2, 1. Now let's try to make this triangle 0, 0, 0. So let's first make this 1 in second row 0. So for that, let's replace row 2 with row 1 minus 2 row 2. Then we will get 2 minus 1, 1 minus 1. Then 0 minus 5, 5 minus 5, 1, 1, 1, 1. Now try to make this one 0. So for that, R3 can be written as, or it is replaced as R2 minus 2R3, and we will get 2 minus 1, 1 minus 1, 0 minus 5, 5 minus 5, and R3 will be 0 minus 3 minus 1 minus 3. Now scale R2 as 1/5 of R2, and we will get 2 minus 1, 1 minus 1, 0, 1 minus 1, 1, 0 minus 3 minus 1 minus 3. Now try to make minus 3 0 here. So for that, we can replace R3 as R3 plus 3 times of R2. So we will get 2 minus 1, 1 minus 1, then 0, 1 minus 1, 1, then 0, 0 minus 4, 0, which is in row echelon form. Now from the third row, we get minus 4z is equals to 0, that is z is equals to 0. And from second row, we get y minus z is equals to 1, that is y minus 0 is equals to 1, that is y is equals to 1. And now from the first row, we will get 2x minus y plus z is equals to minus 1, that is 2x minus 1 plus 0 is equals to minus 1. Minus 1 get cancelled, so we get 2x is equals to 0, that is x is equals to 0. Therefore, x is equals to 0, y is equals to 1, and z is equals to 0. Therefore, we can write it vertically as x, y, z is equals to 0, 1, 0. Now let's try to further reduce this REF form. Then row 1 can be written as row 1 plus row 2, and which will give us 2, 0, 0, 0, 0, 1, minus 1, 1, 0, 0, minus 4, 0. Now row 3 can be scaled as minus 1 by 4 R3. So we will get 2, 0, 0, 0, 0, 1 minus 0, 0, 0, 1, 0. Now row 3 can be written as, or can be replaced as R2 plus R3, and we will get 2, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0. Now R1 can be scaled as 1 by 2 R1, and we will get 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0. And this is in RREF form, where all leading entries are 1 and all other entries are zeros. And we can clearly see that it has a unique solution, that is x is equals to 0, y is equals to 1, and z is equals to 0. So x, y, z is equals to 0, 1, 0. Our next topics are pivots and free variables. Thanks for watching.